Hello students, in previous class we studied about potentiometer, its a principle and its application to measure the EMF of the cell. Today we will study other applications of potentiometer. Firstly, use of potentiometer in comparing EMFs of two cells. EMFs of two cells. We'll draw schematic diagram of potentiometer. This is a potentiometer wire. Auxiliary circuit we will complete. Connect it with by positive terminal of the battery. Connect it with by ammeter, that is negative terminal, positive terminal. Then rheostat. Rheostat connected with key, and this is connected to other end of the potentiometer. So this is auxiliary circuit. Now we have to take two cells whose EMFs are to be measured and these EMFs are to be compared. So we will connect it, this positive end of the potentiometer, with the first cell. Let it say EMF be E1, and the same end will be connected to positive terminal of second cell. These two cells are to be compared actually, and here we will take a two-way key. S1 will be connecting here, S2 will be connecting here, and it will be connected to a load resistance. It will be connected to a galvanometer, and galvanometer connected to jockey. Jockey can be contacted along the length of the potentiometer wire. So this is its a circuit diagram. Firstly, this key is closed. Current will pass through this potentiometer wire. Suppose S1 is closed and S2 is open. Then what will happen? Current will pass through this wire, and its current will also pass. This current will oppose this current. At certain point we will get a balancing point. At a certain point along the length of this potentiometer wire we will get zero deflection in galvanometer. That means voltage drop across the end A and let it be J, VAJ will be equal to EMF of this cell. Given, and as per principle of potentiometer we know that VAJ is equal to KL1. K is potential gradient, that is potential drop per unit length of this potentiometer wire. We have already studied. So VAJ is equal to E1 is equal to KL1. This is equation 1. EMF of this cell is KL1. Now what will we do? We will open it and close this. We will bring it into circuit and this will be opened. Now this cell E2 is in the circuit and this is out of the circuit. This is not taking part in this process. Suppose at this point J dash we get balancing point. That means galvanometer shows deflection at this point J dash, and let this length be equal to L2. Let this length be equal to L2 from this point A to this point J dash. So what is potential drop between point A and J dash? As per definition of potentiometer or principle of potentiometer, potential drop is directly proportional to length of the wire. So VAJ dash is directly proportional to L2 or is equal to KL2, where K is potential gradient, same, its value will be same, is equal to E2. This is the EMF of this cell. So firstly we will bring it into circuit. Then secondly, I will bring it into circuit, and one out of these two will be out of the circuit. In first case, L1 is the measuring balancing length of the potentiometer wire. In second case, L2 is the balancing length of the potentiometer wire. If L1 is greater than L2, that means EMF E1 is greater than EMF E2. If L2 is greater than L1, that means EMF E2 is greater than EMF E1. In this case, L2 is greater than L1. So, what we will do? We will divide one equation by equation 2. Dividing this, we will get E1 by E2 is equal to KL1 by KL2. This K is same, constant for a particular potentiometer. So E1 by E2 is equal to L1 by L2. E1 by E2 is equal to L1 by L2. In this way, we can compare the EMFs of two cells. This is application of potentiometer, which is being used to compare EMFs of two cells. I think it is very clear what we took. We took two cells, and these are connected with positive terminal of this potentiometer by this two-way key, along with this load resistance and galvanometer, and of course with jockey. And this potentiometer wire is connected by auxiliary circuit, which consists of a battery, a meter, rheostat and a key. Firstly, this will be brought in circuit and current will pass through it, and when this current, this potential, this EMF will be balanced by the potential drop across the length of the potentiometer wire by VAJ, and then this will be brought in the circuit, and this potential drop VAJ dash will be balancing EMF E2. E2 is equal to VAJ dash, E1 is equal to VAJ, and comparing these two, we will get E1 by E2 is equal to L1 by L2. So this is the way to compare EMFs of two cells. Another important application of potentiometer is to measure internal resistance. This is called R of the cell. As you know, internal resistance is the resistance offered by the electrolyte in the path of moving ions inside this cell. That is called internal resistance. How to measure this internal resistance? Same, we will take an auxiliary circuit which will be connecting this potentiometer. This is battery, this is ammeter, this is rheostat connected with a key, and this is connected to other end of this potentiometer wire. Now what we will do, we will connect this positive terminal of the potentiometer wire with this cell whose internal resistance is to be measured, and the same end will be connected to a resistance box along with a key, and this will be connected to a galvanometer. Galvanometer will be connected to jockey. Let E be its EMF. So what will we do? We will connect this jockey along the length of this potentiometer wire by flowing certain current with the help of this rheostat through this potentiometer wire. Suppose at point J we get balancing point. That means G is showing zero deflection. If it is showing zero deflection, that means potential difference or potential drop in between A and J, that is VAJ, is equal to EMF of this cell, because this is out of circuit. In this case, this key will be open. In first case, we are opening this key K, and this cell is in this circuit. Galvanometer is showing zero deflection. So VAJ is equal to E is equal to, as you know, equal to KL, provided this distance is equal to L. Means the potential drop across the length L of potentiometer is balancing EMF of this cell. So EMF is equal to KL. Now what will we do? We will close it. When this key will be closed, this resistance box will come in circuit. So current will pass through this resistance box also, and the current will pass through the electrolyte of this cell also. So there will be potential drop across the internal resistance offered by this cell. So if there will be potential drop, so this this potentiometer will be measuring only terminal potential difference, which actually voltmeter does. This EMF will convert into terminal potential difference. Now the balancing point will be little shorter than earlier point. Suppose this is the balancing point J dash. And this length we have taken as L. Let it be L1 in first case. So it will be KL1. And in second case, we make it L2. So now, potential drop will be VAJ dash is equal to, suppose it is V, is equal to KL2. This is equation 2. Is it clear? In first case, this will be out of the circuit. No current will pass this through this resistance box. Current will pass at the balancing point. Current will also not pass through this cell even. There will be no potential drop across the internal resistance. So the balancing length of potentiometer wire will be equal to EMF of the cell. That will be equal to KL1. In second case, when this is closed, current will pass through it. That means through internal resistance also a voltage drop will be there. Current will be passing through it. So because of this voltage drop across internal resistance, the measuring length of potentiometer wire will be shorter than the earlier length. That means L2 will be shorter than L1. So this potential drop will be given by VAJ dash is equal to V is equal to KL2. By dividing equation 1 by equation 2, we get E by V is equal to KL1 by KL2 is equal to L1 by L2. E is equal to V plus I into R by V is equal to L1 by L2. 1 plus IR by V is equal to L1 by L2. I R by V is equal to L1 by L2 minus 1, or R is equal to V by I times L1 by L2 minus 1. This is internal resistance offered by the cell is equal to R, resistance introduced in the resistance box, times L1 by L2 minus 1. This is another application of potentiometer, which is used to measure internal resistance of the cell. Next important application of potentiometer is to measure unknown resistance. To measure unknown resistance. For that also, we will take potentiometer as usual, AB, it's an auxiliary circuit, completed, ammeter, rheostat, key, and this is connected to other end, and this is connected to one unknown resistance. Suppose this is R, and this is connected to known resistance. Suppose this is S and this is connected to galvanometer. It is connected to jockey. When galvanometer shows zero deflection, what will happen? This length L1 and L2 along the length of potentiometer wire will be balancing these two resistances known as and unknown R, and this is condition of Wheatstone bridge. Wheatstone bridge condition is being fulfilled. Means if no current passes through this bridge, through this galvanometer, then potential difference between point J and let this point be N will be 0. If no current passes through this, then L1 by L2 is equal to R by S. This is a condition as per Wheatstone bridge principle. We have studied in meter bridge. So the unknown resistance R can be measured by making use of this formula L1 by L2 into S. This is how you can measure unknown resistance R by making use of potentiometer. In next class, we will be studying a number of questions asked in board examinations based on this important topic, potentiometer. Thank you.